Hey everybody. The last part of my proof got cut off and I didn't realize it. So I'm just going to continue the proof or repeat the proof with all the stuff written on the board. I left off in the previous video right about here. And my next statement was, without loss of generality, the angle x is between 0 and pi over 2. We're assuming, first of all, that x approaches 0 through positive values. So, starting at the x-axis, we move in the counterclockwise direction for positive values. So the angle x is directed this way, and the x-axis itself, the positive x-axis itself corresponds to the angle x equals 0. So certainly, the angle x would have to be between pi over 2 and 0. Now there are some observations that we're going to make. Okay, I don't need pi over 2 and angle 0 anymore. First observation. With reference to this right triangle, origin BA, this right triangle, origin BA, we have a right angle right here. So what is the sine of this angle x? By definition, it's the opposite over the hypotenuse. The side opposite this angle is the line segment AB. So the line segment of measure, or the measure of the line segment AD is the opposite. And the hypotenuse, that's the line segment that goes from the origin to this point B on the circumference. But wait a minute, if the line segment goes from the origin to the circumference, then it's a radius, isn't it? And we're working with the unit circle. See, I'm not sure I mentioned that either. But yes, we are working with the unit circle. So this point is 0, 1. That point is 1, 0. And in the unit circle, the radius is 1. So the radius, or the hypotenuse of this right triangle, is 1. And so sine of x just turns out to be the length of line segment AD. Sine x is the measure of line segment AD. Now, line segment AB is less than or equal to line segment BC. Why? Well, we have another right triangle here. BAC is a right triangle. And the line segment BC is the hypotenuse of the right triangle, of which line segment AB is one of the sides. So the measure of line segment AB has to be less than or equal to the hypotenuse measure of line segment BC. And then finally we have the arc length from the initial side of the angle to the terminal side of the angle. And remember, in the unit circle, the arc length numerically is the same as the measure of the angle. So the length of this arc is just x. And why is the length of this arc greater than or equal to the measure of line segment BC? Well, the the shortest distance between 2 points, B and C, is the line segment having B and C as endpoints. So line segment BC is the shortest distance from B to C. Any other path will be greater than or equal to that. So the measure of the arc, or the arc length, x, is greater than or equal to measure of line segment BC. Now, of all of this stuff in this equality, what am I interested in? The fact that AB is greater than or equal to 0 and less than or equal to x. And I'm interested in that because AB, line segment AB, that measure is the same as sine of x. So I can say that 0 is less than or equal to sine of x, which is less than or equal to x itself. And I'd like to write below that, let me just make sure that I have some room. Oh, I got plenty of room. So I'm going to use the sandwich theorem now, and I compute the limit of all 3 sides . And wouldn't you know it, the limit of 0 is equal to 0. The limit of a constant is the constant itself. And x is a monomial. So it's continuous, which means that the limit of x is equal to the value that we get when we plug this number into x. That's equal to 0. So the sandwich theorem tells us that the limit of sine of x as x approaches 0 is sandwiched between 0 and 0. So what does that tell us? It tells us the limit as x approaches 0 of sine of x, is that going to fit? I think so. The limit as x approaches 0 of sine of x equals 0, which is exactly what we wanted to prove. Yeah, I think we just barely got it in. Okay. Since we're on a roll, at least I hope we're on a roll, let's prove one more theorem. Okay, the limit as x goes to 0 of cosine of x equals 1.
So we'll assume that x approaches 0
through positive values. Epsilon's supposed to represent some tiny value. So we'll say epsilon is greater than 0, but we'll say also that it's less than 1. As we did in the case with sine of x, that we'll assume that the angle x is in the first quadrant, between 0 and pi over 2. This is what we just got through proving. And this is going to imply that the limit as x approaches 0 from the right of sine squared of x equals 0. Now, why is that? We can reason this way and say that sine squared x is equal to sine x times sine x. And therefore the limit as x approaches 0 of sine squared x is the same as the limit as x approaches 0 of sine of x times sine of x and we have the limit of a product there, but we know that the limit of a product is the product of the limits voila. Okay. So the limit of sine squared x is 0 as x approaches 0 from the right. Now, what does it mean that the limit as x approaches 0 of sine squared x equals 0? It means that there exists a delta such that x minus 0 less than delta implies what? Implies that sine squared x minus 0 is less than epsilon. This is what it means when we say the limit of sine squared x as x approaches 0 equals 0. it means there's some delta such that x minus 0 less than delta implies that sine squared x minus 0 is less than epsilon. And we can simplify that a little bit.
Yeah, we can say that
X is positive, isn't it?
okay, so x between 0 and delta implies sine squared x is less than epsilon.
And maybe these don't have to be equal. Okay. Let's use this somehow. Oh, let's see. Why is all of that true? Well, let's see. 1 minus epsilon is a number that's between 0 and 1. And when we compute the square root of a number that's between 0 and 1, we actually get something that's larger than the original number. Think about it. The square root of 1/4 is what? 1/2? See, the square root of 1/4 is larger than 1/4 itself because it's a number between 0 and 1. So 1 minus epsilon is a number between 0 and 1. When we compute the square root of that, we get something larger. And let's see, why does this inequality hold? Sine squared x is less than epsilon. So that means that 1 minus sine squared x is larger than 1 minus epsilon. We're subtracting a larger number from 1 here than we are from here. So 1 minus sine squared x is larger than 1 minus epsilon. And when we're talking about positive numbers, and we compute the square root of two numbers, the square root of the larger number is larger than the square root of the smaller number. Think about it. The square root of 9 is bigger than the square root of 4. The square root of the larger number is larger than the square root of the smaller number. So that's why this part of the inequality holds. And 1 minus sine squared x is cosine squared x. And since we're in the first quadrant, cosine of x is positive. So when we compute the square root of cosine squared x, we get cosine of x. And now let's see. Why is that less than 1? Because x is in the first quadrant between 0 and pi over 2. In order for x to be equal to 1 in the first quadrant, in order for cosine of x to be equal to 1 in the first quadrant, x would have to be 0. But x is an angle between 0 and pi over 2. Greater than 0, less than pi over 2. So, yeah, 0 less than x less than pi over 2. And I'll emphasize x is not equal to 0. So cosine of x is less than 1. Let me just write that down again. 1 minus epsilon is less than cosine of x, which is less than 1. Those are the parts of the inequality that we care about. Well, let's see, if cosine of x is less than 1, then it's definitely less than 1 plus epsilon, isn't it? Ooh, what does it look like I'm about to do here? Let's see, 1 minus epsilon less than something less than 1 plus epsilon. Oh my goodness, what am I about to do here? I'll tell you what I'm about to do. I thought I knew what I was about to do. Oh. I'm not as dumb as I look, and nobody can be that dumb. Okay, here we go. Yeah, I kind of sort of knew what I was going to do, but not exactly. I needed to subtract 1 from both sides, okay. Huh. What does this mean? It means absolute value of cosine of x minus 1 is less than epsilon. And what was epsilon? It was just some positive real number. Well, if this is less than epsilon, essentially for all positive epsilon, I know what that means. It means cosine of x minus 1 has to equal 0. Okay, the absolute value of something equals 0. That means that whatever is inside the parentheses is 0. That means that cosine of x is equal to 1. Now, is that really what I wanted to do? Let me think about this. No, that's not what I wanted to do. Oh my goodness. Please forgive me. Yep, just erase that from the video that I'm making too. Let me summarize what we just established. Okay, there we go. X less than delta tells us cosine of x minus 1 is less than epsilon. And what that means is, limit as x approaches 0 from the right of cosine of x equals 1, which is what we were trying to show in the first place. Okay, I think I'm going to call it quits here. I can't think anymore, obviously. Maybe tomorrow I'll think better. Enjoy the video, and it's good to be back.